All right, I don't know if my previous video saved, but I was working on, let's see, what's today, the 23rd? All right, heading on, let's see what's, wait, that's the video I just did. That's crazy. Okay, okay, cool, we did have it. The whole computer crashed. I don't know if it was just a weird thing. I don't know if it was the program itself, but we're gonna try to not have that happen again. But what we're doing is admin code day 5, which is the last one I left off on, and in that video, and I might cut them together or whatever, I don't really know how that works, but I refreshed my memory on what the problem was, where I left off with the program, and trying to figure out like where the issue is. So to reiterate that, I guess just restart, yeah. So the problem is, you know, you have two chunks of input. First is this chunk, which is some number dash some number, which is the range of it was happening when I opened Mecha keys, so maybe I don't open Mecha keys this time. It happens when you, actually I want to open Mecha keys. Let's see what happens. This is stupid. Program's not running this time though, so maybe that'll be fine. We'll see. Okay, cool. So yeah, you have the these are essentially values that will be the, what do they call them? The fresh, fresh ingredient ID ranges means like you have all these numbers which are the quote unquote good values, you know, 3, 4, 5, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 12, 13, 14, 15, 16, 17, 18. So those are your values that you kind of are, that you have as a pool of available values in a way. Well, that was actually really poor phrasing, because these are actually your available values. But so what you do is for each of these values, we check, hey, does this value exist in one of these ranges, in any of these ranges? So the way my program did that was, it would take this, it would then parse out, okay, we need 3, 4, 5, add those to a list, a dynamic array. 10 to 14, add that to the same array. 16 to 20, add it to the same list. 12 to 18, add it to the same list. So we end up with this, oh shit. Okay, no. I don't want to run that again with long. I don't know if that's what caused my computer to crash, but we don't want to do that because that's stalling out. So you'll have this array, which will be all these values in the given ranges, and you can see there are repeats, 17, 16, 17. And then you have these values itself, which are just simply in an array. And the way the program is working right now, if I'm guessing correctly, we're just going through each one of these and checking, hey, is this in this array somewhere? Which is simple enough for this sort of input, but the problem is when you have these type of input where the numbers themselves are massive, the difference between these, like the range itself is massive, you know, and all these are the values you're checking, like it's obviously a lot of potential. It's a very large list potentially, right? And when I was just messing with this before my computer crashed, what I was trying to do was see, you know, hey, where in the process are we stalling, right? There's kind of 3-ish parts, right? There's parsing the fresh ranges, there's parsing the available ranges, and then there's searching the fresh, searching in the fresh values for the available values. So I put this print statement here that would happen once the input parsing gets to this point right here, where we're now parsing the availables. This did not print, so clearly just parsing the ranges itself is a bottleneck, which makes sense when you have input this big. You know, that's fair, it's understandable. So we'll want to figure out a way to optimize this and, you know, make it not stall out. So that's kind of unfortunate, because the note I left for myself when I last worked on this was, hey, you know, look into using a set of some sort, because I was thinking the bottleneck is going to be not really parsing the input so much, but rather but rather searching in the list for the given, the given values down here. Because of course, when you have values this big, the list of fresh ingredients IDs is really large. So searching in an array is pretty inefficient as opposed to like using a set of some sort. Add on top of that the fact that we have duplicate numbers, it's like, well, it's gonna take a while. But that's obviously not the actual bottleneck because this print statement didn't actually happen. So what I'm gonna do now, let's just see how many. I want to see how many things there are. So there's 173 lines or so of ranges. So I kind of want to get some print statement to see how fast this is working. Actually, yeah, let's do that first. Let's just do that first. Let's just call this line, let's call it I. If I is I mod, I just want to do every 10 lines print something. And print I. See how so let's see how quickly it goes through 10. Okay, it's going so slowly, I think it's reasonable to actually just print out I every time. Because if it doesn't even get through 1, then that's, well, that's worrisome. Yeah, okay, so it might actually, the issue might actually be with just individually parsing a single one. So let's actually make a new input file. And let's just grab this first range up here and put that in there. And let's just try parsing this range. So kind of get rid of all of this, or comment it out for now. So let's kind of, well, let's think about this. What can I use as parse input function? All I want to do is grab the part that we're doing, append fresh IDs. So this is what I want, because append fresh IDs, what it does is it takes a string, which is going to be like, something like this. It then parses that range, and parsing the range will take a start and an end and just tell you what that is. Okay, it'll tell you. Yeah, it'll tell you the first. It'll like return in a way through the parameters. For example, 16 and 20. It will then take that, loop through that range, and append all those values in that range. So let's do that for this. Let me just do a split so I can see both parts of the code. What we want to do is, we don't even need to use a different input. We can just put the string right here. Okay, so that's the string we're parsing. Now, something to check though, are these... Okay, I was gonna say maybe these inputs can be invalid, like this number could be larger than this one, which might cause an issue, but in this case, it's not the problem, so we'll just keep running with this for now, and if that's an issue later, we'll solve that if we need to. We have the string, and then we want to parse the range, and how is that used again? Parse range with the string, and then start, we'll just call it A and B. And one thing to note is that A and B need to be initialized to -1, because that's the way, I believe, that's the way that parse range knows which one it should be populating. Because if you're running through this range, a string, you're parsing a string like, 16 to 20, you're going through and you're saying, okay, we need to grab this as a number, right? And we need to know, hey, do we want to store the current number that we're at in the start variable or the end variable? Well, the only way to know which one we should use is checking what the current value is. Like, for example, if we're right here and we're saying, hey, we need to store this number somewhere, we'll need to check, hey, does start currently have a value other than -1? If it does, that means we've already stored it, which means this is now the end value, right? Because we're looping through the string. Yeah, we're separating it. Dash, yeah. Anyways. So we have that, do this, and then let's just sanity check A and B. Segmentation fault. Okay, interesting. These numbers too big? Let me just do normal numbers. 16, 20. Okay, something's wrong here. Does this need to not be like this? What's the issue here? Okay, this is something I ran into before, wasn't it? Where it's like strtoke, how do you pronounce that? I don't know, string token, doesn't work on a char star, it only works on a char array or something like that. But that's not the case down here, is it? Because, oh, see, we're using a line here. Okay, yeah. Why does strtoke not work on char star? Oh, that's right, because strtoke inserts null characters at some point. If it's just a char star, it's a literal, it can't be modified. Sure, makes sense. Okay, what about this now? Okay, so that works. We grab those values correctly. Cool. Then what's next after that? So we append fresh IDs. And then we'd say for each one in that range, but that might be a massive range. Like, let's see, for example, B minus A equals, like, how many values are there in that range? I mean, a lot, right? What even is that? Oh, God. Like 2 trillion? Is that 2 trillion? A lot. Okay, so that's problematic. Interesting. What would be a good way of doing that? Okay, so instead of storing every single number, we'd want to store pairs of starts and ends, and then say, you know, for a given number, instead of saying, hey, is 8 in this list of single numbers that have been expanded from this range, you'd say, hey, is 8, let's compare it to each pair. Okay, 3 to 5. Is 8, you know, greater than this and less than this, or greater than equal to, less than equal to? No, okay, check this one. Is it in there? No, okay, is it in there? No, okay. So we want to store this as pairs instead of singular arrays, or singular, you know, scalars in an array. We want to store it as pairs, because then all you're doing is comparing, is it in this range, rather than, you know, is that specific value in there? It's a lot more, that's a lot more iterations and work to do, right? Okay. So to modify the code to have pairs. So let's just create a pair struct. pair. We can call it a range maybe. Start and end. Okay. So in parsing input, we can keep this the same, that's fine. But instead of appending fresh IDs, I want to maybe make a function append fresh ID range. And what would that look like? We'd still want a dynamic array. I mean, technically, with the input being fully accessible to us, we can just say, hey, we know it's not going to be more than like 175 ranges, you know, pairs. I don't know, do you call it a pair or range? I don't know. We could just do that, but like, let's just make an array of pairs. Now let's just, I should be able to modify the dynamic array. I can make this into a range. Now let's just do it. Let's just have an array of ranges. So the idea is, instead of fresh IDs, this is going to be, I like to count my stuff out so I remember how the code was before, just in case I need it. We're going to have a range. Is range ambiguous? It's kind of confusing. I mean, does pair make more sense? Pair is more general, so let's just do a pair. So let's have a pair, an array of pairs. Append fresh ID pair. So this will be similar, where we takes in some string and then the actual array itself, which would be a pointer to some pair, which would be an array. Because append fresh IDs, yeah, it takes a string, it takes that. And the way that would work is we would say, first off, if we're appending a fresh ID pair, or we're not really appending anymore because we're not using a dynamic array. I kind of like the dynamic array though, so let's just do another one. And in maybe, I don't know if there's a better way to do this in C, to be honest with you. I know in like C++ you'd have like some sort of templating situation, but for this, I mean, let's do what we can do. Dynamic array pair. I mean, that's kind of gross. That's kind of gross, but I think that's what we're going to do. This is a dynamic array of pairs, so we'd have our data. And we need a similar append. Dynamic array pair append. We'd say our temp would be a pair, size of pair. Does that work? I don't know. We'll even move this above that. Maybe. The variable naming is definitely not ideal. It's a little, to me, even a little confusing. Ambiguous dynamic array pair, dynamic array. I mean, it's kind of weird. Is there any sort of templating or anything in C? Like if I have a dynamic array struct and then some functions that do dynamic array things like appending and resizing within this appending logic when appropriate. I don't know how to allow this dynamic array to work for multiple types. Longs, ints, other structs, etc. Is this just not possible in C? Yeah, it's manual, that's a thing. Oh, you could use void type. Interesting. Can I just do that then? Can I just do that? Dynamic array append. What's the thing? I would need to know what the type is right here. Yeah, let's just not do it that way. It's definitely possible, but let's just do it this way and kind of just see how it goes. Okay. So what we'd want to do is come down here and say append fresh ID pair. We pass in the line, we pass in pairs, which is in our dynamic array. Okay. So this would also be dynamic. Oh, dynamic array pair. Dynamic array pair. And that would be dynamic array long, so we need to go through and change all that. Dynamic array long. See, that's shitty. See, I don't like, it just gets kind of messy, man. See, that's poor, that's definitely poor convention to have this be the default. It's a certain type. It's just whatever, but it's whatever. I'm just trying to make it work at this point. Okay. Kind of all over the place right now. I need to just do one portion and then make sure it builds and iterate on that. We take this here, pairs. Let's just comment this out for now. Let's see what the errors are currently, because I know I'm going to have some. Huh. Interesting. Let's comment this out. Let's get this back and change this to be short. Okay, yeah. That's not going to work because it's different types. Instead of fresh IDs, we say dynamic array pair. Pairs. Create dynamic array pairs. See, this is what's unfortunate. It's just like kind of weird because it's like create, because the struct type is dynamic array underscore pair. So to say create, it's just a weird convention that doesn't feel right to me. And over here it was like saying you'd have like vec init, vec push. I guess it's the way to do it, honestly. You have like dynamic array pair. I mean, that's just weird. That's just weird, man. Could be like DA pair, DA long. Don't like that either, though. Okay, we allocate the dynamic array. We then set the capacity based on the arg passed in. We set the we allocate for the data, which is the overall capacity times the element itself. We return that array. So we need a return dynamic array pair pointer. Okay. I want to change this to dynamic array long init. Create dynamic array. What do I call this? Oh, where was I? What the fuck? Oh, right here. Dynamic. Okay, cool. Should also change these because I keep going back and forth on that, but let's just do it. Here too, long. Dynamic array long print. In a way, this makes this code kind of unreadable, but you know, I don't know. It's at least consistent in a way. Okay. Dynamic array long push. Change this up here to long. Append fresh IDs we don't really need. Dynamic array contains, we don't really need to do that one. Well, are we using that? Do inventory, are we using that? Oh, sure. We'll need to modify that, but let's just change this function name. Dynamic array long contains. This will take long. Well, this will need to be modified overall, to be honest with you. Something like that. Okay, let's see how many errors we get there. Fresh IDs is not a thing. Fair enough, and we should be passing in pairs now. Fresh IDs is not a thing. Let's do this. Pairs, and let's add that function. Let's modify this function and make it work for pairs. Oops. We take new value. Oh wait, this is push, but I want print. We'll need this too, actually. I want the print function though. Dynamic array pair append. This one will need to be renamed as well. Array pair push. Wait, that's what I just did. Okay, the print statement or the print function is what I want to copy now. Okay, cool. Instead of printing, well, that's printing the size and capacity and then the data itself, where each data would be a pair. So we'd actually want to print. I mean, I suppose it makes sense to call the data pairs, right? Should probably get rid of this and do it up there. Okay, so print, we do data, we'd actually be pairs. Each pair we print. Let's do it like some weird syntax. A equals something, B equals something. And the pairs will be long still. The values of the pairs will be long still, so that's fine. Pairs.a. Let's do pair. Make it a little more readable in that print statement. Something like that. There's no member named data. I mean, it kind of does make sense to call it data though, doesn't it? Makes it more general, but like, I kind of see in this context it makes more sense. So you go back and forth with these kind of design things. You know, I don't know. Fresh IDs, line 196. Do inventory, we'll do that after. Because that still obviously needs to work. Count. Okay, at least it's building now. So now we actually make it work. So when we're parsing fresh, because right now, if I run it, we have nothing here, which makes sense because there's nothing ever added because we never called this. So each one we want to append fresh ID pair, which is kind of a function that takes care of all that for us. We want to compare it to the other one, append fresh IDs. Wait, where'd that go? Okay, right there. So we want to do something similar to this, except in this case we already have our. Sorry, so each time we append fresh ID pair. So this involves parsing the range. So we would need to say, at this point in the code, we would have an array of pairs, a dynamic array of pairs. We need to make sure that based on how the parse range logic works, we need to make sure that pairs.data for whatever the next element would be that gets appended would need to have the A and B value both be -1, because that way the parse range works properly. Well, really what we can do is just, we might be able to just pass in a pair itself, right? And up here we'd say pair dot a equals -1, -1, so that can be used properly. And then we'd come down here and we'd say, hey, if pair dash or a is -1, let's actually not overwrite that. Let's actually comment that out and look at it this way. So if a is -1 means, hey, we haven't stored anything in a yet, let's store it in a. So we'd say pair a equals that value. Same down here, but for b. Right, parse range and store in a pair. Whereas before it's parse range and stored in 2 longs. So we don't need to initialize it down here. Then we can just say parse. Well, we still kind of is the same logic where you need to tell it where are we putting this at. Because before we're grabbing these values separately. Oh, you know, honestly, that does still kind of make sense. We still can do it that way. I think we actually can still do it that way. Because what we're going to do is just use these start and end values as kind of temporary values. You know, pass those in here. And then simply append that to the dynamic array. Right? Push, and we push, you pass in the array itself, and the new pair. So we actually wouldn't need to modify parse range at all, I don't think. I mean, you can do it either way, realistically. So I don't think we need that at all, right? Does that even make sense? Okay, I think it actually makes sense. Cool. Wait, hold. I think it actually worked. So we now have a pair. Let's actually change that print. Let's just change this to be like that. So now we have a pair. Actually, we need to add that space there as well. Okay. Now we have a pair of 3 to 5, 10 and 14, 16 and 20. Okay, that makes more sense now. That's going to work better, I think. I think that's going to work better. Because now, when we go through here, when we do our inventory, really is what I need to modify now. We'll take our fresh IDs, which is actually a pair, an array of pairs. Fresh ID pairs. And then we'd say, okay, so for each one, and we still might need to optimize this, but I think this will still be an improvement at least. I mean, because again, clearly the bottleneck was, at least initially, you know, there's probably later bottlenecks as well, but initially the problem was just parsing the input. It took forever because you're looping through 2 trillion, you know, values for a single range. So this at least will save that. Now we still might need to optimize this later for other reasons, but let's just see how far we get. So for each available ID that we want to check, we would then, instead of checking, hey, does that exist in the array, we'd say Let's just do it in this. We can break it out into a function if we need to. We could say for each fresh ID, each element in the fresh ID ranges, which is an array of pairs, j less than fresh ID ranges dot size. If the current element, let's just say avail ID equals data I. If the current fresh ID range, so let's call that a pair, fresh ID range. So let's just call it, let's call it fresh ID range equals fresh ID ranges data j. If the avail ID is greater than or equal to fresh ID range dot a, and it's less than or equal to the end of the ID range, then we can say, hey, that's in our inventory, count can be incremented, right? Pairs undeclared. Count is 4. What should the actual value be here? 3 are fresh. Wait, I'm getting 4 for some reason. Why am I getting 4? Oh, we'll want to break. Yeah, because we're essentially saying, like, for example, if we're looking at, let's say 17, what we're doing is saying, hey, is it in this range? No. This range? No. This range? Yes. This range? Yes. We'd count it twice. We don't want to count twice. Okay, cool. So that seems to be working. Let me get rid of all these statements up here. We actually can get rid of this function too, I think. I don't know, I like leaving stuff. You never know if you'll need it. And then once I'm actually done, I can remove it all. It's kind of nice to, in one fell swoop, remove a bunch of old code. Array contains is also not used, comment that out. Print statements are used, init statements are used. Checking if it contains is potentially necessary or useful, but not really for this specific use case. So inventory is kind of just a function that does a bunch of stuff for us to help solve the problem. Let me move this init function up by the other init function. The print, init, our push functions should be somewhere right here. I want to put all the dynamic array stuff together. Cool. Cool. Append fresh ID pair, is that's still used, okay. Yeah, cool. Dope. Oh wait, we're still printing a bunch of stuff. I don't necessarily need that. Okay, let's see what happens if we do the long input now. See how far, let's see if we get anywhere. Oh, nice, okay. Let's just see if it worked. Nice. Oh, that was sweet. Now, I'm not dedicated to doing part 2, but let's just read it and see how much harder it is. Okay, they'll start bringing their spoiled inventory back to the trash chute so they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ID range is considered to be fresh. Oh, interesting. An ingredient ID is still considered fresh if it is in any range. Wait, what? The elves would like to know all of the IDs that the fresh ingredient ID range is considered. So all the values in here. The ingredient is still considered fresh if it isn't. On the second section of the database, the available ingredients is irrelevant because we're no longer checking available ones. We're just saying, hey, what are all of these? I'm guessing they just want a count of all of these. The ingredient ID range that these ranges considered to be fresh are 3, 4, 5, 9, 12. So no duplicates. Okay, that's interesting. So I still don't think, obviously, based on how large the input is, that actually going through and doing each value in here is a good idea. But the problem is, if you're not doing that, if you're only having two kind of numbers denoting what the range is, how do you account for duplicates, right? How do you account for duplicates? Because if I know that we have a range of 10 to 14 and 12 to 18, I know that there's duplicates here because there's overlap, right? So how do you kind of more smartly determine that? You'd have to like compare starts, the end values to start values and vice versa. Like say, okay, is this value in one of these ranges? If it is, we'll need to subtract that number. So for example, we say, okay, 14, is that in any of these ranges? No, we're invalid because we're checking that one, irrelevant. Is in this range? No. Is in this range? Yes, it is. What's the difference between this value, and because it's the end, what's the difference between this value and the start of this range that it's in? Well, the difference is 2, because well, it'd have to be both of these. Interesting. That's interesting. I don't know if I'm going to work deeply on this one because I feel like I'd rather do like a part 1 of different problems to at least be able to say I got, you know, all or most of the problems solved in some capacity rather than having some solved completely. But that is an interesting one. It seems like a fun problem to solve. Yeah, so you'd want to go through and say, for each range, check it's weird. It's weird. It's like you want to say, is this start value within this range or any of the ranges? In this case, the start value is in this range. Okay, cool. And because of that, we know there's going to be at least some duplicate overlap values. So the way to do that is if we have, let me draw this out. Maybe that'll be easier. I don't know if it actually will be, but it's worth trying. So if we know we have 10 to 14, let me change this color. Can I not change it more than that? Thick. That is not thick. Okay, that'll work, whatever. So if we know we have 10 to 14, and we also have 12 to 18. Say, is this value in any of these? Let's just assume this is these are the only two ranges, so we don't have to worry about checking anything else. Is this value within any of the ranges? No, it's not. Is this one? Yes, it is. Okay, cool. So now we know we have some sort of duplicate situation. What do we do about it? Well, we'd say, try to figure out the relationship between these sorts of double duplicate situations. Like this is in this range. Does that necessarily mean that this value is going to be in this range? It would have to be, right? Because what you're saying is this value is greater than this value and less than this value. And if this value is greater than this value, that means this one's less than that, which means it goes in there. Not necessarily though, right? Although it would have. Let's say, for example, we have 10 to 14. No, I guess it would, right? What if we had, okay, how about, what if we had 13 to, it's the same thing. Yeah, so if this value exists in this range, then that means, let's just draw this out. So we have 10, 11, 12, 13, 14, then we have 12, 13, 14, 15, 16. And I did not draw that very well, but that's okay. We'd have 3 overlapping values, which means we need to make the overall count less than 3. Because right here, 10, 11, 12, 13, this is, 5 elements. This one is 6 elements. So you think, oh, we have 11 elements overall, but really we only have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So we need to say 3 elements. Wait, 9. Oh, 7. So you'd think we have 12 elements, but really we have 3 duplicates, which means 12 minus 3 would be 9. So the idea is to figure out with this sort of overlap logic how many duplicates we have. Okay, I guess first step would be just for each range, subtract, b minus a, add that to the overall count, right? And that's the raw number of values we have, counting duplicates. And then we'd go through and do this overlap logic, figure out how many overlaps there are, and then do count minus overlap. And that'd be the number we're looking for. Sure. But how do you, the problem is this overlap logic, how do you actually implement that? That is the challenge, huh? So we really need what would help us is a function of is overlap, right? We need a function of is overlapped. And we'd have pair 1 and pair 2. So for a given pair, we'll then compare that to all the other pairs, which would be pair 2, and kind of iterate through that. What would this look like though? Say if we'd want to check p1.a, if p1.a is, well, that's the thing, you could have that still, right? If p1.a is less than p2.a, that doesn't mean anything. It could be less than or greater than, and we'd still have overlap. For example, 10 to 14 versus 12 to 18, there are overlaps in this. There are duplicates. 10 is less than 12, okay? It doesn't mean anything. We could also have 13 to 14 versus 12 to 18. Again, so in this case, p1.a is less than p2.a, doesn't mean anything. Here, p1.a is greater than p2.a, doesn't mean, so I think comparing a's is not going to be beneficial or insightful. I'm guessing. to kind of continue looking at cases to see if that's true absolutely or not. But comparing A's to B's and vice versa, that's probably a little more useful. So if P1.A is less than P2.B, if it's less than, obviously it could be a valid thing because that's what we're looking at with this example. What if it's as simple as P1.A is less than or equal to P2.B, and so this guy's less than or equal to that, and this guy's P1.B is greater than or equal to P2.A. Let's see if we can come up with some cases that prove or disprove this. So 10 to 14 versus 12 to 18. Well, that'd be P1.A is less than P2.B, and then also P1.B is greater than P2.A. Okay, sure. And what about if that's not the case? What if, for example, P1.A was greater than or equal to this? So let's say some number here, 14 versus 12 to 18. So this second statement would still be true. P1.B is greater than P2.A. But let's say this guy's, well, that wouldn't be possible. Because if this guy's, if the upper bound is greater than, wait, that's not right. Yeah, if the upper bound is greater than this, then this could, yeah, if they both are. So like, for example, if we're at like, let's just say 20 to 23. If we're at 20 to 23, then we could say that P1.A is greater than P2.B, and also P1.B is greater than P2.A. So that'd be true. Okay. That would not be a duplicate. There's no overlap there. So for the overlap, would this be an OR situation though? No, it wouldn't be, because that's what I kind of just did an example of. If the starting value is greater than this, then that means, then if the starting value is greater than this max value, then by definition, this value, which is greater than this value, would also be greater than this. Be greater than both of them, actually. I'm thinking this is it, and let's just see if that works. We can kind of keep working through handwritten like cases and try to figure it out, but let's just kind of see if it works practically.